Namaste, welcome back to Practitioner channel. You are watching AWS Cloud Quest Cloud Practitioner video game. We did 10 quests so far, and as Cloud Practitioner we have 2 more quests to do. Once those 2 quests are done, we are not ending the series because we still have different roles. This role was Cloud Practitioner. We are going to continue as Solutions Architect after 2 more quests. And once the quest for Solutions Architect is done, then we are going to do mostly networking or no. We will do data analytics. Maybe after that security, and after that machine learning, and so on and so forth. If you have a recommendation, instead of me doing the next one, Solutions Architect, if you want me to do networking or machine learning, you can leave a comment and let me know. I will do it. It's up to you guys. If you don't recommend me anything, I will go ahead and I will pick Solutions Architect. That being said, let's do our 11th quest. Before that, let's try to make this as our friend. VPCs can be peered across AWS region. Yes, cross account possible, cross region, VPC peering. When we created the peering, they asked us accounts. Yeah, I think it's possible. Let me look at the hint. Okay, okay. Instances in either VPC can this is okay. You can create a VPC with 2 own VPCs or with a VPC in another AWS account. The VPCs can be different. Yes. Finally, something. Okay, in order to get Twilight as our friend, we need 5 more quizzes. Okay, so let's go do our 11th quest. This quest is going to be this quest is named Highly Available Web Applications, and we are going to help the travel agency create a highly available web application architecture. And let's hope once we finish that, they will at least give us a huge discount on our next flight. So let's go ahead and do it. How do we go there? We will take a shortcut by clicking on Route and Go. We are going in the other direction. Okay. Oh, okay, I think they are there. Oh, there is another pet. I think there is a horse. Maybe we will get it later. Yeah, we cannot get giraffe as our friend. Hi, thank you for answering our request for help. Our travel agents just had a disastrous promotion event. Oh, I'm sorry to hear that. What happened? The promotional event we held last week increased our web traffic and overloaded our website. All requests were being timed out. Seriously, when you do a promotion, that is something that you would be expecting. Worse than that, our EC2 instances were also hosted in an availability zone that was affected by severe storms. That is unfortunate. We were offline for hours. I'm so sorry this happened. Let's talk about how you can prevent it in the future. First, you can use AWS to create an auto-scaling group across multiple availability zones, ensuring that your resources aren't isolated, which is something we did in our previous quest. Second, you can create a load balancer so that network traffic is distributed equally across your servers. Makes sense? Okay, so if I spread instances out over multiple availability zones, will that make it 100% safe from failures? No system is 100% fail-proof, but availability zones reside in geographically distinct locations, and a singular event is unlikely to affect multiple availability zones simultaneously. Got it. But how would we verify that our site is down in a different availability zone? After you spread your EC2 instances over multiple availability zones, you can attach an load balancer to your auto scaling group to ensure high availability and elasticity. You can also monitor EC2 instance health by setting up a health check on your load balancer. We have learned that yesterday as well. This sounds promising. Can you build this system for us? Our site needs to handle the increased demand. Will you help us make our travel booking site highly available? I will only accept on one condition. If you throw a to and fro ticket for me in it, then I will. Okay, so before accepting, let's look at our rewards and objectives. Rewards, they increased. Previously we were getting 50, 55, but looks like we are getting 80. I think we are going to get 10 experience with EC2, S3 and ELB. And the learning objectives, we are going to learn how to create an auto-scaling group across multiple ages. I thought this we already learned in the previous one. Maybe they will let us do again. And then how to create a load balancer, how to attach an auto-scaling group to load balancer, create a load balancer health check for EC2 instances. Let's accept it. Thanks for helping. You are welcome. Okay, here is our architecture diagram, and as usual we have video concepts, and as usual all the video concepts, all these videos that you see here, I'm not going to play them, but they are already uploaded to our YouTube channel on the playlist AWS tutorials for beginners. These are all numbered. You can go ahead and watch all of them and then come back to this if you want to learn more about these topics. If you don't, then you can continue watching, but if you do, all you have to do is go back to AWS tutorials for beginners on our channel playlist. Okay, now let's look at the diagram steps. This classic web application architecture uses an AWS cloud computing infrastructure to ensure that application is highly available. Here we have Route 53, which provides DNS services to streamline domain management. CloudFront is used to deliver static and dynamic content. CloudFront can cache frequently accessed content to decrease latency. S3 is used to store static assets such as images and videos. ELB is used to distribute traffic across multiple availability zones. Amazon EC2 auto-scaling groups are deployed for redundancy. Auto-scaling creates groups of servers that grow or shrink in capacity depending on the demand. Auto-scaling also works directly with Amazon CloudWatch for metrics data and with ELB to add and remove hosts for load distribution. For example, if a web server reports greater than 80% CPU utilization over a period of time, an additional web server could be quickly deployed and automatically added to the load balancer. So those are the steps, and we also have Amazon RDS. Obviously this website backend is a database, and in case if this fails over, they have a maybe active passive. No, which one is this? Okay, it's a standby. So they do have a failover to another database even for this. So this is highly available. Now let's click on the plan, and as the practice lab, we are going to migrate an auto-scaling group behind an ALB in one availability zone. Then we are going to set up load balancer health monitoring for Amazon EC2 auto-scaling group, and then we will add a second availability zone to the EC2 auto-scaling group. I think this one. As DIY, I think we will configure an auto-scaling group to include a new instance in the third availability zone. Okay, that's exciting. It's exciting. Okay, now let's go click on Start Lab. We have 44 steps, guys. So let's get started. Okay, we will go to EC2. By placing your web servers in an Amazon EC2 auto-scaling group behind the load balancer, you can achieve high availability for your application. We already learned about it. And then they want us to go to auto-scaling groups, and looks like they already created an auto-scaling group called Travel Agency Web Servers. Remember, in our previous quest, we already learned how to do it. So that's why I guess they already created it for us. And they put desired minimum maximum capacity as 1111. These define the boundaries for the number of instances allowed in the auto-scaling group. The desired capacity is the initial capacity of the group, and the capacity it attempts to maintain. The auto-scaling group in this practice lab example can currently contain only one instance. Then they want us to click on instance management and review the instance ID. An auto-scaling group starts by launching enough instances to meet its desired capacity. It maintains this number of instances by performing periodic health checks on the instances in the group. We already learned that. If you remember, in the previous quest, we actually did create that, and where we had the option of picking an ELB, we said we don't want pick ELB. Step 5, they want us to pick the details and then scroll down. Maybe there is something else that is left for us to see. You must specify at least one availability zone when you create your auto-scaling group. An auto-scaling group can be configured across multiple availability zones for increased availability. Then they are showing us the availability. This one is East 1A, and then that is the subnet that is associated with it. You define which subnets from one or more availability zones are linked to the auto-scaling group. This defines where your Amazon EC2 resources linked to the auto-scaling group can reside. And then they want us to edit the load balancing. And when you attach a load balancer to your auto-scaling group, the load balancer registers with the group and acts as a single point of contact for all incoming web traffic to the group, right? When you attach ELB, what happens? All the traffic will first come to the ELB, and then ELB will decide what server it needs to send it to. Then they want us to add a new load balancer, and which one we are picking? Application. You should know the difference. This is at network level 7, this is at network level 4. They want us to pick HTTP, HTTPS, then internet facing, right? It's not internal, it is internet facing because we want this to be the internet facing. Choose the application load balancer to manage web-based applications that require HTTPS connectivity. The load balancer must be internet facing if your web applications are for public access. In our case, that is what is happening. Then they want us to pick all the zones, and from this they want us to pick all public ones because this is ELB and it has to be able to connect to public, so all public subnets. Then they want us to create a target group, and new target group name is that. Can I copy the name? I don't see it. That's fine. Travel agency web servers -1. Load balancer takes requests from clients and distributes them across targets in a target group. After you enable an availability zone, the load balancer starts routing requests to the registered targets in that availability zone. Right? These targets are nothing but our auto-scaling groups that we will see in a minute. So before I forget, let me go and start the lab or open the lab, and let's start doing what they showed us so far. Okay, so first they asked us to go to EC2. Then they asked us to go to auto scaling on the left bottom, and they wanted us to go see the details, and you can see the desired one, minimum one, max one. They wanted to see the instance, and you can see the instance associated with this auto scaling group is T3 micro. Then they wanted us to go back to details, scroll down, and yes, US East 1A and this subnet. They wanted us to add the load balancing and add a new load balancer, and here we are picking this one, and load balancer name, did they tell us what name to pick? I don't remember. Anyways, internet facing. They wanted us to select all of this, make sure they are all public. This is private. Public, okay? Because it doesn't make any sense for you to put it in a private, then public internet cannot access it. Select a new or existing. We are going to create a new group, and that will be our new group. Update, I don't know if they want us to do anything. Let's see. Oh, then they asked us to click update. That's fine. Then we are going to create new security group. To customize the traffic flow between the load balancer and the web servers, you can create new security groups that define what traffic is allowed to the load balancer and what traffic is allowed to the web servers behind the load balancer, right? So let's click next, and they want us to name it that, and description something, and the VPC, very careful picking VPCs because in the last lab we picked wrong VPC and I had to debug. So it is travel agency VPC. Cool. Security groups are assigned to a VPC. This means that the security group can be assigned only to resources within the VPC. Okay, let's go ahead. First of all, I don't want to confuse you guys. Update. Okay, let me scroll down. Once that is done, let's go to security groups. Create a security group, and they want us to name this. Where is the description? I didn't use the description here. It is here. Okay, make sure you don't leave this. Last time I did that. Go ahead and pick this one. Okay, then we are going to give inbound and outbound rules. Remember, security groups, you can only give allow rules. You cannot give deny rules. You can do both allow and deny rules for what? Network ACLs. You need to remember that. So we are going to obviously let HTTP in, and we are saying everyone. Okay, and outbound rules is what? So inbound everybody can, but outbound who can go? Only this security group, and this security group I am assuming belongs to the EC2 machines. I am assuming. Let's see. For destination, in the custom search box, choose the travel agency web server security group. Yes, that is what it is. Okay. Outbound only, where will it go? It will go to this security group alone, and that is the security group of the web servers. For a public facing load balancer, you specify all zeros as a source to accept traffic from any address. By specifying a security group as an outbound destination, you can restrict traffic to be sent only to instances associated with the specified security group, which is what we will do. So let's go back. Inbound rule, it's HTTP, and this is going to be 00. Outbound rule, again HTTP, and this is going to be, we scroll down under security groups, we have travel agency web server. Okay, done. Yes, done. Security groups are not active unless they are assigned to a resource. Obviously, if you don't assign them to anything, they are not active. What happened to this? Okay, let's go back and select this, create it. Okay, once that is done, they want us to go to the web server security group, because load balancer we allowed it to the outbound, right? But we need to let the inbound also do that. So that's why we are all the web server, we need to go ahead and tell it accept traffic only from the load balancer security group. I think that's what they will make us do. To increase security, you can edit the security group used by EC2 instances behind the application load balancer to allow only inbound traffic from the load balancer. See, that's what I'm saying. I know this stuff. Okay, now we went into the web server security group, and we are telling allow HTTP requests coming from, is this the security group of that one? Hold on, we'll see. No, this is the existing one. So that's why I confused. This is allowing everything. So we have to delete it, then add the security group of the load balancer here. By removing all zeros source and replacing it with the security group, you can control which resources are allowed to send traffic to instances without having to input address ranges. Only traffic from the instances associated with the security group are allowed. I think which is what they will do. See, they are adding the load balancer security group HTTP. So only traffic coming from this can go into the web server. This is the securest way you can do something. Okay, then save rules. Then they are going to the load balancer. Custom security groups are active only after you assign them to an instance. You can assign multiple security groups to an instance. We already know that. Okay, so what do they want us to do? Go to the travel agency web servers and then go security, edit it. We'll go back there in a minute. It looks like I'm lost for a minute there. Okay, once we are done with this, let's go here. Pick the web server one. Actions, edit inbound rules. We are deleting the all zero. Add a role, HTTP, and here security group, the load balancer. Save changes. Okay, and they went to the load balancers for some reason. Okay, we have this one active, and they went into the security. That's what I feel like. Yes, this is that security groups that you associate with your load balancer determine your rules for controlling where traffic can come from and where it can be sent. And I think it already has the security group available here. Okay, in security group section, under security section, click the X to deselect the web server. Oh, okay, previously it was using the web server. Now we are going to remove that and attach the security group specifically created for this load balancer. Yeah, that is right. Then let's save changes. Okay, now we have that is the DNS address for the load balancer. So anybody who wants to communicate with the web server, it will hit this one first. So to test access to your application through load balancer, you can copy the DNS name into your browser and enter it. I think that's what it will show. Use the DNS name to get quick feedback and view your application. If you don't see your application, be sure to check the rules in the security group that associate. Maybe indirectly they are saying you screwed it up somewhere. Okay, right now it is web server, but we don't want the web server one because the web server security group should be attached to the web server, not the load balancer. So let's go ahead and pick our load balancer security group. Save changes, done. Now what they are saying is, if whatever you did is right and didn't screw up anywhere, copy the DNS name and open it. And remember, when you are opening it up, to make sure it is HTTP, not HTTPS. Okay. So here we are. I copied the URL somewhere and opened it, and as you can see, it's a success. So I didn't mess it up anywhere. Right? That's awesome of me. But anyways, so let's go click next. Now that is what, okay, health. Okay, they want us to hit /health. I think that is the path they are using to figure out if this particular URL or server is healthy or not, I guess. The default load balancer health check validates only the root path of an HTTP server. Applications generally will implement a much more robust application health check to validate server configuration and external access. You can manually verify that health checks are active on your load balancer. Okay, so it looks like they already created this. So let's try that. Health. So if I click that, it is saying instance is healthy, which is good. That's all I need right now. Then they want us to go back to the target group that we created a while ago, and they want us to click on health checks, and let's edit the health check. You can modify load balancer health check settings to match your performance requirements, obviously. Okay, so right now that is what is there. After your target is registered, it must pass one health check to be considered healthy. After each health check is completed, the load balancer node closes the connection that was established for the health check. Okay, and then they are telling us healthy threshold and unhealthy threshold, the number of consecutive health check failures. If 2 are failure, then we will consider that as unhealthy. If 5 consecutive checks are success, then we will consider that as healthy. and it will time out how much seconds after we want to time out a response failed health check. And it's all about configuration. They want us to give 5 2 to 5. The default settings allow 150 seconds to pass, 30 seconds intervals time for 5 unhealthy checks before marking an instance unhealthy. The new values will cause unhealthy instance to be marked unhealthy after 10 seconds. Okay, remember those numbers 2 to 5. Now let's go back and edit what they want us to edit the availability zones. I think they want us to add the other 2 availability zones as well. Before that, let's go back, and they wanted us to go to target groups. Select that, and health checks, edit it. We already have that. Sorry, here it's supposed to be health advanced, and we want this to be 2 to 5. Save changes. Okay, now once we are here, they want to again go back to load balancers. Select that. Security, no, not security, I guess. We will just go to details. Is it details? No. Let's see. They went to auto scaling groups. Sorry, that is the auto scaling groups network. After you have created an internet facing load balancer, you can now run your applications in a private subnet. You can add or remove subnets associated with the auto scaling group. Now we will make sure that auto scaling group lies in private subnet. It doesn't have to be in public subnet. Okay, so now there we are going and we are editing the subnets of it, and we are deselecting the public and selecting the private one, and then we are updating it. If you add or remove a subnet, you are defining where the auto scaling group resources can reside. And then we are going to terminate the web server, I think, to change the subnet. Okay, because it is pointing to public. Since we right now have the elastic load balancers in public, we are just making sure that other resources that comes after all stay in private. So right now everything is public. We are just changing everything to private. Changing the subnet will not automatically cause instances to rebuild in the auto scaling group. Terminating the instance reduces the number of instances below the minimum for the auto scaling group and invokes a new instance launch in the private subnet. Okay, remember that. Okay, it won't automatically rebuild it, so that's why we need to terminate the instance. Okay, let's go ahead and change these public subnets to private subnets. So let's scroll down, and they are asking us to go to the instances, then pick. They asked us to terminate it, didn't they? Okay, so let's go there, and then let's terminate the instance first, because they have the public internet. The only way you can change is by terminating them. So let's go to our lab, go to instances, and we have our server here. As you can see, it has public subnet. Actions, instance state, terminate. Yes. Now once we do that, let's go back, and after a few minutes, they're asking us to restart it again, looks like. Click instance to expand or choose terminate. In the pop-up, click terminate, go to next steps. Okay. After a few minutes, click the refresh icon. The instances list should show that a new instance was created. Okay, since we already have created auto scaling group, as soon as you terminate this, auto scaling is spinning up a new one. But if you see, this new one will have private subnet. That is cool. We don't have to change anything. If you terminate an instance within an auto scaling group, which results in lowering the number of running instances below the auto scaling minimum requirement, which we put as 1, a new instance is launched automatically. That's awesome. Now once that is done, they want us to go back to the auto scaling groups, click the activity, check the history, because you can review auto-scaling group operations in history. That will show that it just created a new instance, if I'm not wrong. Yes, the successful launching new instance. Each item in activity history lists an auto-scaling action and the cause of the action. So let's go and check that. Okay, so if you see, this is showing it's terminated. Let's refresh, and as you can see, it automatically created a new one and it's already running. And if you look at this, what, it still has a public subnet. This is not right. This has a, it's not showing, but this is not supposed to have public subnet. Somewhere we missed something. So let's go to auto scaling groups, click on this. Let's see activity what it did. It did launch one, but whatever it launched is not what we wanted. So somewhere we did something wrong. Let's scroll down and let's look at the network. I thought, didn't we remove this and pick the private one? We did pick the private one. I don't know why it didn't pick that. That's weird. Okay, let's update it again. Now let's make sure it is private. Is it showing? It's not showing, but yeah, it's private, which is good. Now let's go back to our instances. Go here, terminate it. Yes. Now whatever EC2 instant it is going to spin, it should spin it with the private subnet. Alright, here we are. It launched a new one, and let's hope at least this one is in private, and I can see it is in private because it doesn't have a public IP address associated with it. And here we can see it successfully created it in private. Now they want us to go back here and check the history, which we already did. Activity, if you go here, successfully it launched it. Okay, that's that. Now let's go to our web, whatever web server, by copying the DNS name of the elastic load balancer. Let's check if it is healthy or not, which is something that we already did, but let's do it again. Right, it is healthy. We are able to successfully connect to it and it is healthy. Be sure to get verification by the load balancer. Now they want us to go there, edit the network, and I am assuming they want us to add another availability zone to take advantage of the safety and reliability of geographic redundancy. Span your auto scaling group across multiple availability zones within a region. Attach a load balancer to distribute incoming traffic across those. I think by now we already know. We already picked one, so let's pick the second one. When one availability zone becomes unhealthy or unavailable, Amazon EC2 auto scaling launches a new instance in an unaffected availability zone. Auto scaling attempts to launch new instances in the availability zone with the fewest instances. Okay, so let's do that. Choose, click auto scaling, choose, and they want us to again modify, I think, even this minimum capacity. The desired capacity is the initial capacity of the auto scaling group after this operation completes, and it's the capacity that the auto scaling group attempts to maintain. Desired capacity is what auto scaling changes based on the instance performance or other alarm based actions that you configure. They want us to change it to 212. By changing desired capacity manually, you can test your auto scaling group behavior, increasing the desired capacity while not exceeding the maximum capacity. Will launch new instances to meet the desired capacity value. Okay, then we can go back to activity and review those. Load balancer can use connection draining to complete in-flight requests made to instances that are deregistering or unhealthy before stopping traffic flow from the load balancer. Once that is done, they want us to select the, which one is this? Okay, they just want to see the, new one that got provisioned to have the private subnet too. When autoscaling launches a new instance, you can verify the subnet ID to ensure that your instance was deployed to the correct subnet, and then check whether it is healthy or not. And if you refresh it multiple times, it might show the other instance as well. Okay, so that is about it. So let's go and do that. So the first thing that we need to do is go to autoscaling group, unselect, select it, and we need to go ahead and details, go to network, and let's add the other private subnet as well in this, update it. Now let's go to the autoscaling. No, actually it is right here. Let's edit this. They want to update it. Okay, now if we go to our instances, it should automatically try to create a new one. Let's give it some time. Here we are. As you can see, it is initializing the second one. So if we select that, let's see where it created it, and it created it in subnet 2. The other one, it created it in subnet 1. Okay, so one is ending with BC, another one is B52. So previously BC it showed whenever we hit the load balancer. Now it can, since it's load balancing between these two, it can change one or the other whenever we select them. So let's see, once it is healthy, we will try this option. It is still initializing. Let's give a few more minutes. Finally, it finished its status check and it is available. As you can see, one is available in A and one is available in B. So remember these two, BC and 552. So now if I go and hit on the ELB's DNS name or the URL that we got, it switches between these two. Okay, because it's a load balancer obviously, so it is going to. So let's click on that. So now we got 52, the new one. Clicked again, I got BC, again 52, again BC, again 52, again BC. You are seeing it, right? So the load balancer is working successfully. At least that's what we can get out of it. All right, so that will finish the practice lab, which we finished. And I think even the DIY is very easy. I think they are just asking us to configure autoscaling group to include a new EC2 instance in a third availability zone. Okay, so all we have to do is repeat whatever we just did. Let's go back to here and we need to go to autoscaling, unselect, select, scroll down, network, and let's add the third private subnet. I think it is this one. Update it. Okay, we have it, but now we need to increase this capacity as well. Otherwise, how would you know if it will spin there or not? Update it. Now let's go back to instances and wait for 5 more minutes, and then we will have the third one. By the time it is doing that, oh, it already started it, and you can see it is spinning it in 1C. So our DIY is asking what? Your application load balancer name. Application load balancer name. I think this is the load balancer name, if I am not wrong. And then they are asking for autoscaling group name. Autoscaling group, and its name is this. Okay. I don't know why the load balancer name is that. Load balancers. Yeah, that's what our load balancer is called, unfortunately. Instances. Let's see. This will take some time though. What? It terminated it? Why? Huh. Interesting. Did we do something wrong with the autoscaling? We said minimum is 1, desired is 3. Yeah, we have set it properly. Let's see what happened. Failed to update target group. The following instances do not exist. Yeah, they do not exist, but why? It was started in response to a difference between desired. Okay, yeah, it started, but why did you fail it? That's interesting. Is it doing that again? Okay, right now at least it is running. Not sure what is going to happen. Okay, let's go back, enter it, validate. In the last exercise we initially got, you didn't do it, so we had to go and fix something, but right now you did it. All three availability zones are covered by instances behind a load balancer. Now return to the city and give your customer the good news. Congratulations guys, if you're following with me and did this without doing the same mistakes I did, then you are more awesome than I. But at least with this quest B, at least I learned how to create elastic load balancer, how to create auto scaling groups, and how to modify its network, how to modify its capacity. Then we learned about how to turn public servers that are in public to private, right? A lot of good things we learned today. Okay, let's exit. Now let's go and give the good news. This is great. Our site is back up. It's now highly available and the increased traffic is no longer an issue. Now choose a reward. They all look almost the same. Let's pick this one because this has a board, or not a board. Yeah, even this one has. Yeah, that's fine. Okay. And now you know what it's time for. It's time for feedback and rewards. We leveled up both the builder and our level. Okay, so let's give the feedback. 5-star as always because I loved it. And this is time for you to give feedback to this video for me as well. So please go ahead and like the video and comment, leave a comment, and if you haven't subscribed yet, go subscribe to this channel so that you don't have to miss awesome content that I will be posting. And this channel has broad number of topics. You might have seen it. Go to the playlist and check the playlist to see what are the different things that I am posting. And in coming weeks I have plans to post MuleSoft certification questions, and I have plans to post Cloudera certification questions. I think Cloudera we already did. I'm talking about Snowflake, my bad. So Snowflake, MuleSoft coming up next week. So don't forget to subscribe to this channel if you don't want to miss all those awesome things, and do hit on the bell icon so that you will be notified whenever I post all these awesome videos. And you might be noticing even the AWS tutorials for beginners library is increasing. Right now we are at like 52 videos. Go check them out. If you like, you know what to do. Hit like. When you hit like and comment on this video, I will post other videos in this series more often. You already know. So more activity on this video will give you more videos in this series. If I don't see much activities, people liking or commenting, etc., subscribing, then that will only tell me that you guys are not interested, so I don't spend time on this. Instead, I will spend time on something where people are more active and people want more videos. For example, like AWS Cloud Practitioner certification question analysis, right? There are so many people who are active on it, who like, comment and subscribe for that video. So I post them because they want more videos every day. So I literally post one video every day on that. That being said, let's go to our next item, which is zapping these blue ones and answering all the questions until we see repeated questions and collect cards. Once we collect cards, my internet got disconnected, so I had to re-log in again. Here we go. Let's hunt these blue drones, and it's the normal drill. We hunt these, collect cards, then we will do orange ones. When a load balancer detects an unhealthy target, it stops routing traffic to the target even when the target becomes healthy again. It stops routing to that target, we know that. I don't think so. I don't agree with it. Yes. Okay. Because once it becomes healthy, there is no need of avoiding it. So instead we will go check it again. If the status is healthy, we will go and use it or route the traffic to it. Which targets for an application load balancer are valid? We missed this. We didn't check this, but let me think about it. I think instance, lambda and IP address. I don't think you can have a database as a target. Yes! Today I'm rocking. Yesterday I had a couple of wrong questions. Which statement regarding auto scaling and load balancing is true? It can only have one. No. Auto scaling groups must be used independently. No. A load balancer will route traffic to all targets, no matter which availability zone the targets are in. Load balancers must use the same security group as instances behind it. Nope, that is not true. We just created 2 security groups for these two, so this should be the answer. Yes! Okay, let's go with this. Select this. What do application load balancers use to verify that traffic should be sent to a target? Okay, used to verify with what do you do? Okay, it is the health check, right guys? It is not scaling policy, because this is not a auto scaling. It's not security. Used to verify that traffic should be sent to a target. Is it health check? No. Is it? I think it is one of these. Let's click on hint. It's confusing. The question is confusing. Yeah, since it's talking about health checks, it is. I think it is health checks. Okay, let's click that. Fingers crossed. Yes. Auto scaling group. Let's go. What happened? We don't have any here. It's all I hits today. A user causes an auto scaling group to drop below the defined minimum by manually terminating an instance. What is the outcome? We know that it is going to create a new instance. To learn to measure, because we already did it, right? Whatever we did it is similar to whatever this question is asking. When we stopped or terminated the instance, it took it to below the minimum, so it created another one. I am assuming this is a blue one. Remember this building I picked? What can be used to restrict access to specific Amazon EC2 instances? Instance level, it is security groups. I think the questions are repeat. Oh, it asked for 2. Come on. VPC peering connection can be established only between 2 VPCs. Yes. That's not fair. Okay, let's do. It's time for our orange ones or yellow ones. Let's hope it will give us one with where we have the cards. Okay, good. It is giving us the one where we have all the cards. Your team wants a more reliable architecture to better serve customers. Someone suggested that during peak times, the team should increase the number of EC2 instances, place them in multiple availability zones, and distribute the traffic accordingly. Literally, they are just talking about what we did. Okay, so we have the web application, and after that we are going to have elastic load balancer, which is this. And after elastic load balancer, we are going to have auto scaling, which should be here. And we are going to have our server sitting here. Okay, so that would be here we go. That's it. They just asked us what we just learned, and it is correct. Alright guys, so I will end it here. If you are practicing, go ahead and do more quests and earn more cards. But I don't want to waste your time. Oh, this looks nice. What is this? A snowman. Is it a real snowman? No, it is not. It's just penguins. Is that a fox? It is fox. And there is one more snowman. This is nice. Okay, that being said, I appreciate your time for watching these videos. I really appreciate it. Thank you very much and have a great day. See you in the next one. Peace out.